Hello, everyone. My name is Brett Newman, and I'm the VP of Marketing and Customer Engagement for AI and HPC at Microway. We have a great webcast for you today. Welcome. It's about building intelligent chatbots using retrieval-augmented generation. We've brought in some incredible experts from NVIDIA on this topic, and we can introduce to you a little bit about how Microway is the right partner for your retrieval-augmented generation workload in designing, architecting, testing, and deploying the hardware and software solution that you need to run on. So without further waiting, let's move on and introduce our partners at NVIDIA, who can begin to teach everyone about this topic.
My name's Amanda Saunders, and I'm here part of our enterprise AI product marketing team, particularly focusing on generative AI and LLMs. So excited to be here at one of the most exciting techniques and use cases that we've seen in the generative AI space that is just taking off across businesses everywhere. These AI intelligent chatbots that are using retrieval-augmented generation to pull in enterprise data and provide incredibly powerful, accurate tools that can be used by business functions everywhere. We're going to jump into the details. Today, I'm joined by Jacob Lieberman. He's part of our enterprise AI product management team, and he focuses on building some of these retrieval augmented generation workflows for our customers. So let's jump right in and see what's going on in this space. I think it's safe to say that as we've looked at generative AI and LLMs and their adoption and what we're seeing from enterprises, that this is the future of how enterprises are going to work. These AI assistants are going to become prevalent in our world, whether we're consuming them from the applications that we've already used today, or whether they're things that are unique to our business that we're building and offering to our employees, to our customers, to make their life better, faster, easier. So we know intelligent chatbots are going to be the next killer application. You've heard it's the year of the co-pilot. You've heard it's the year of the AI assistant. These things are only going to grow in our use and our adoption across the enterprise. Humans are going to change the work they do. It's not going to be so much about manual lookups and gathering information. Instead, they'll be directing teams of LLMs to pull together these desired results from all sorts of different sources that have all sorts of skills and domain understandings. Enterprises are going to have hundreds to thousands of these AI assistants, whether they build them themselves or consume them from others. And it's going to literally be across every job function. IT spend is being already increased to support these AI initiatives. The new co-pilot features, they're no longer seen as a IT cost sink. They're actually seen as productivity gains, as revenue gains. So they're actually being funded at higher rates than we've ever seen before. And of course, we know that these chatbots need to have access to proprietary information in order to be as efficient and productive as we need, which is why this topic of retrieval augmented generation is so important. So I've already in this presentation, I've used chatbots and copilots and agents interchangeably, and in most cases, this is fine. And when we're talking about these things, that makes sense. But I did want to cover some of the differences so we can think about what we're trying to build, what are the capabilities it needs to have, and how do we go about building these intelligent assistants. So it all starts with chatbots, and chatbots are what we've come to know. Historically, they've been sort of pre-programmed. They had a certain set of skills and answers that were built into them. But with LLMs, they've become much more intelligent. So they're able to answer questions with human-like interactive capabilities. They're able to find information, deliver it in very human information type ways. Great for question answer use cases, and really powerful tools that we can add to our employee and our customer experiences. We then get to co-pilots. These sit alongside your employees and they actually perform specific tasks. So things like writing, generating code, generating images, all of these different things, these are considered co-pilots that they work alongside your employees and help them do their job faster and more efficiently. Microsoft Copilot is certainly the one we hear a lot about. There's also Sidekick by Shopify, GitHub Copilot, many other examples that live out there today. And then we get to AI agents. AI agents, this is sort of a broader term. It encompasses numerous different technologies, including the chatbots and the AI assistants. Think of things like Siri and Alexa. These are agents that can handle very complex tasks and can interact in again, fun, human-like ways. Now, all of these AI assistants, whether it's chatbots or copilots or agents, are more powerful when we connect them to our own proprietary data. And that's what we want to talk about today, this concept of retrieval-augmented generation. So let me turn things over to Jacob so he can go into some of the details of the solution and why it works to build these intelligent assistants.
Hi folks, my name is Jacob Lieberman and I'm a product manager at NVIDIA. And today I will be sharing a bit about using LLMs in an enterprise context. Now, working at NVIDIA, I sometimes wonder if the technology trends and changes that we see every day are also seen by other people in the industry. Sometimes I wonder if we're the tip of the spear. These are common kind of issues, but if you are new to using large language models, you've probably heard all the hype, and you may be wondering if they really are a big deal, if they're really worth all the hype. And in my opinion, the answer is yes. I believe that in the very near future, LLMs will be used by everyone to do everything, and that is not an exaggeration. Large language models completely change the computing landscape, and the closest thing I can compare it to in my lifetime is probably the popularization of the internet or personal computing or mobile computing. It's really that big. So this is a massive change, and not just for enterprises, but in every industry. But in an enterprise context, there are some unique concerns. LLMs by themselves are not accurate enough for many enterprise tasks. Now, most of what you hear and what you read about large language model accuracy comes from, let's say, an academic world, the world of data scientists and researchers. And typically, when discussing the accuracy of an LLM, it's usually in the context of comparing two large language models performing the same task. And we often hear things like, this model has 98% accuracy, so it's comparable to that other model that has 99% accuracy. And this is completely fine and sufficient if you're building and comparing models. But enterprises care about predictable business outcomes. So in an enterprise context, it's probably better to think about accuracy in terms of failure rates, doing some task. And if you think about accuracy as a failure rate, a 98% versus a 99% accuracy means you're getting one failure in 50 versus one failure in 100. And that is a huge difference in terms of predictable business outcomes. So in an enterprise context, it's not difficult to imagine a world where large language models need to guarantee 5 nines accuracy, as is the norm for service uptimes in an enterprise. So, now just to get to the topic of what's on this slide, what are some of the ways that large language models can be inaccurate? Well, first of all, off-the-shelf large language models can't chat with you about your own enterprise data. They were not trained on it. They are only trained on the data set that's available to them. And this does not include the data that's deep in the belly of your SAP or Oracle databases. And this means that an off-the-shelf large language model cannot generate insights specific to your enterprise data. Second, large language models can become outdated as soon as the model that they were trained, as soon as the data that they were trained on also becomes out of date. They have a shelf life. So a trained model might be very accurate, but only aware of information that was available to it up to the point at which it was trained. And in an enterprise context, you could have information changing very quickly, changing in real time. And last, large language models often don't know when they don't know an answer. So they might confidently return an answer based on incomplete information. In AI parlance, this is called hallucinating, but this is something, for example, my children do. I remember I was talking to my son once about, kind of the pre-cooked and the cooked weight of food and how they might be different. And he said, well, that makes no sense because when you put it in the microwave, it adds heat. So it should be heavier because it puts heat on it. And, I thought that was funny. I think he was 5 at the time or something like that, because really he reasoned from the basis of what he knew. But in essence, he was hallucinating like a large language model because he came to a conclusion wrongly, even though there was nothing wrong with his reasoning. So how do we reconcile the power of large language models with these limitations? Well, as you've probably already guessed from the title of this slide, we can do it with retrieval-augmented generation, or RAG. I think that I have been told I shouldn't be saying RAG, but it's inefficient to say retrieval-augmented generation all the time. I will try to do it, but if I mess up and say RAG, I apologize in advance. I talk about this probably 10,000 times a day, so it's a harmless mistake. But at its core, the retrieval-augmented generation approach is about enabling large language models to provide the most current and domain-specific answers by connecting them to live enterprise data sources. This helps ensure that the information they generate is both accurate and current. So on this slide, you can see a picture of an abstracted retrieval-augmented generation pipeline. The big picture idea here that the slide tries to convey is how this approach works. Starting on the right, you have your enterprise data. This might be PDFs, documents, structured databases, mailboxes, audio, video. All of these data sources are transformed into a common representation format through a process called embedding. And embedding vectorizes the data into a form that the large language model can understand and query and incorporate into the existing knowledge that it's trained with. Here on the slide it says text embedding, but actually it's possible to embed many different types of data, including text. So the embeddings that are created are typically stored in databases that are purpose-built for efficient interaction with large language models via specialized search algorithms. And the result is that retrieval-augmented generation, by connecting your enterprise data to the large language model and transforming it into a representation that the model can understand, you've now transformed your generalist LLM into a specialist, and it's a specialist on your data. This means that the responses generated by the system reflect the latest and most relevant enterprise data available to it. So enough talking. No presentation or webinar would be complete without a demo. And here I have a little video of a retrieval augmented generation example that a few of our tech marketing engineers put together during an internal Hackfest. So I'll play the video. It's about 1 minute long, and I hope the audio comes through my microphone here, so I don't have to re-record this. But I'll play the video, you can see the demo, and then I'll just point out a few things when it ends.
Okay, so the first thing we're going to see is this bot's ability to stay on topic thanks to the integration of Nemo Guardrail. Now, the question is, tell me about the US president. As you can see, the bot say I can only answer questions about NVIDIA technology. Now, the second thing we're going to demonstrate is that if we are sending questions such as this, the difference between performance of A100 and H100, it will go off and look through the NVIDIA tech blog and not only answer the performance difference, which is 2.2 times, as well as the image reference so you can verify it for yourself. Cool. And now we're going to demonstrate a new feature that's being implemented during the Hackfest. User is allowed to upload an image and ask questions about it. So both text and image as input. Here we go. And then had to wait a little. So here's the response. So as you can see, it's saying that it's a 7% of a difference.
Okay, so just a few interesting things to notice. First of all, this is a multimodal RAG pipeline. So it can chat with you about text and images. And the images here are business images, graphs, tables, etc. And so, this is an important feature because if you think about the documents in an enterprise, the information density of a graphic may be higher than all of the surrounding text combined. So the second interesting thing about this is that they're using Slack as the interface into the chatbot. So Slack is kind of a developer productivity and communication tool. We use it heavily inside of NVIDIA. And so putting the Slack as the interface into this chatbot makes it available to our users in the typical way that they go about their job. This is not a special thing they have to visit with a special interface. It's just kind of embedded in their daily workflow, enterprise workflow. Third, the example shows some guardrailing capability. Everyone's favorite thing to do when they first try out a large language model, probably the first thing is they ask it to write a poem. And the second thing is they try to get it to talk about inappropriate subjects. So here in the demo, they ask it about politics, who is the US president, and it does a good job. It doesn't engage in the political talk. I wish I could follow its example because sometimes I do that online. And I think that the most important thing that this video shows, of course, is the retrieval-augmented generation capability. So here they're using an open source model. The model was not trained on NVIDIA technology, but it could answer questions about the GPUs using data that was provided to it through an NVIDIA knowledge base. And then they went one step further and they actually uploaded a graphic into the Slack channel, which got embedded into the database in real time. That's why there was a slight delay. And then they could chat with the Slack bot about it immediately. Now, this is just a proof of concept, but within NVIDIA, we're already using these technologies daily to deliver real business value. For example, you can take a screenshot of an error you're seeing on your laptop and send it through Slack to a large language model managed by our IT department, and it will help you troubleshoot your error. And that, I think, is an important idea to understand, is that in addition to evaluating the accuracy of your chatbot, probably the most important evaluation metric is that it has some measurable business outcome. So I guess I'll talk a bit more about that later. So the idea behind retrieval-augmented generation is simple. You connect a large language model with your own data so you can chat with it. But for an enterprise leader, a decision maker, the massive ecosystem of commercial and open source components that have popped up all around the industry to deliver this capability can be a bit difficult to negotiate. So on this slide, I'm going to try to simplify things by looking at the technologies that make up a retrieval-augmented generation pipeline as 4 key technology areas. So let's start with the foundation model. The foundation model is pictured here in the lower left. These are the large language models, and here you can see a few popular examples such as Bloom, Falcon, and Llama 2. There are commercial models such as our own Nematron models. There are open source models, and dozens of new models seem to be appearing every day. These models represent the brain power of the system, and each model has its own strengths. But I would say that collectively they're more alike than they are different. They're fundamentally trained to understand and generate human-friendly text and interactions. Moving to the top right, we see the text embedding systems. These interpret and encode text in a way that machines can comprehend it and process it efficiently. So you can also use embedding models to do this that can run on a GPU. Ada, Dragon, and NVIDIA text embedding models, we also have models called involved models, are a few of the embedding models pictured here. And then at the bottom, we have the vector database, and you can see there are many options. Chroma, which runs in memory, Milvus, Pinecone, Redis, and others. These are the repositories where encoded enterprise data is stored and made available to the retrieval system to generate responses efficiently. And finally, we have data frameworks. This is the yellow or gold box in the middle. The data framework orchestrates efficient interaction between all of the different parts of the pipeline. And LangChain and Llama Index, which are the ones shown here, are two of the most popular open source frameworks for programming retrieval-augmented generation pipelines, but there are many others. And so for the enterprise leader, the challenge is clear: how to select, implement, and maintain a retrieval system that delivers real business value in a rapidly changing environment and ecosystem. Okay, so we talked about using large language models in an enterprise context and how we can think of accuracy as failure rates, with the ultimate assessment of accuracy being the business value that the large language model delivers. We also talked about the limitations of large language models and how supplementing them with a retrieval-augmented generation system can bypass some of those limitations. And we looked at a demo and then talked about some of the principal components of the pipeline. So what does all of this have to do with NVIDIA? What is our unique contribution to this changing technology landscape? So I did show you a kind of a basic demo, and everyone that you will talk to will have amazing demos for proof of concept. But what we're finding is that it's a huge jump to take a retrieval augmented generation proof of concept and put it into production in an enterprise context. So NVIDIA can deliver a top to bottom generation system that eliminates the guesswork of stitching together your own system from all of the components that are available. And not surprisingly, we have technology to help optimize every stage of the retrieval augmented generation pipeline for enterprise use cases. NeMo is the blanket product family name for many of the components related to RAG and LLMs. The NeMo platform has tools and capabilities to deliver every aspect of large language model lifecycle management, from training to customization to deployment. And the NeMo platform can also be used in an enterprise context to deliver production-grade retrieval capability with the scalability and performance that NVIDIA is known for. So just looking at this slide, you can see how some NVIDIA technologies map to the various stages of the retrieval and generation pipeline that we talked about. So first of all, the NVIDIA Rapid Software Development Kit can be used to accelerate vector database performance with the GPU, both during the data indexing and during search and retrieval. Moving up, the in the NeMo Retriever service can also GPU accelerate the text embedding process of using AI models while using AI models that are commercially viable and export compliant. And of course, NVIDIA has best in the industry model serving with an LLM optimized version of TensorRT and our scalable Triton inference server. All of these components combine together into a production-grade enterprise system with commercial software support, and everything is nicely integrated and can be sourced from a single vendor. And but it's also critical to note that even though NVIDIA can deliver a top-to-bottom retrieval-augmented generation solution, there's no vendor lock-in here. Anyone who's worked with NVIDIA knows that we always have an NVIDIA option, but we also partner with everyone to accelerate and parallelize and make their solutions scalable and performant. When it comes to retrieval-augmented generation and LLMs, our approach is no different. The architecture is modular. Every NVIDIA component can be replaced with leading open source or commercial alternatives. Now, it's still kind of early days. Even though it's moving quickly, it's still early days, and there's really no standardization yet in terms of APIs or interfaces. But we endeavor to work with everyone who is willing to work with us, including all of the major cloud vendors and cloud service providers, and all of the leading open source communities who are working in the large language model space.
Thank you so much, Jacob, for going through that. I think seeing really is believing when it comes to these applications, understanding the power of being able to talk to your data, literally ask questions the way you would ask questions of a colleague. So I think as we look towards the next generation of these applications, it's important to understand why the value is there. And I think the first benefit, of course, is that improved accuracy. We talked about that. Being able to connect an LLM to real-time, to domain-specific data without having to train that LLM improves the accuracy, reduces those hallucinations, and makes it more powerful for the users who are asking questions. The natural language interface is key. This is the way we're going to interact with everything in the future, whether it's websites, whether it's applications, and of course, if it's data. We're going to ask questions the way we'd ask questions of a colleague, and those LLMs are going to understand and be able to process that information. Contextual understanding, of course. Models themselves are trained on generic data, but by connecting them to these vector databases that have that semantic retrieval, we are able to understand not only the specific pieces of data and the specific prompt that comes in, but also all those pieces of data that are associated and around that data, so we can provide more nuanced answers. Reduce training costs, certainly. When it comes to these large language models, training can be expensive. And so for many use cases, there's no training needed. You can use models out of the box and run that inference. And if you do need to do training, you can use some of the lighter weight customization techniques or alignment techniques that get you that accuracy you need without having to do, any sort of major training on that model, because the data that you're providing it is providing that additional information and context. And of course, improved efficiency. These RAG systems, these retrieval augmented generation systems, are able to provide the diverse outputs by connecting different data sources without having to change any accuracy or efficiency. The same model connected to different data sources can give you those answers that you need across the different use cases that you have in your organization. So when I said organizations would have hundreds to thousands of these, the applications are all going to look roughly the same. It's the data that's going to change those outputs to the user. So as we've been working with organizations on building these use cases, I wanted to talk about sort of the steps that it takes. Because I think a lot of people think, well, it's AI, it's got to be complicated, it's got to be a long process. And the answer is retrieval augmented generation gives us a fast solution that we can test, evaluate, and scale in a relatively short period of time. We've seen companies who've gone to sort of human evaluation in a matter of weeks. And I think that's a really powerful way to test and have successful outcomes in these markets. So the first thing is starting with that POC or that use case. And the recommendation is to start with some internal use cases that you don't have to worry about data access or IP concerns. The reason is this is simply an easy way to get started. Things like support documentation, corporate communications, employee experience or HR tools, sales communications. These are all things that almost any employee in your company should have access to. So building applications on that data should be relatively safe and an easy way to start, but also impactful. Then you need to set up your POC environment. Now, of course, if you have accelerated computing in your data center, this is an easy step to do. If not, and you want to get started quickly, the cloud is obviously the fastest path to get started. But plan, if you're looking at on-prem, for not only the environment for the initial POC, but what might be needed to scale and run further POCs as you're building out additional applications. Then you're going to leverage the RAG workflow that Jacob talked about. This is a standard workflow that you can follow. Think of it like a recipe, a cooking recipe. You follow the steps, you use your data, and you're able to get a working chatbot in, again, a very short period of time. The next thing you're going to do is evaluate the performance, and it's great. There are many public benchmarks out there that are going to help you evaluate, but more importantly, it's understanding your users. And you can either have human testers in your environment, or you can extend to maybe write your own test evaluation questions and see what kind of answers you get back. You can then automate that process, and as you make continued improvements, you can see how that changes the accuracy of these models. And then, of course, once you've got something that is highly accurate, that gives you the performance levels you need, that's when you want to be able to scale out to as many users as you can or as many users as you need, so that you can start the process all over again and look for that next POC use case. Now, in these sessions, I always like to highlight a little bit of the NVIDIA technology that we've built to help users as they're going through this journey around generative AI and building intelligent chatbots and things like that. Now, as Jacob mentioned, our platform is designed to be open. It's designed to work with the open source community, with our partner tooling, but these are pieces of the platform that we've built to help our customers as they're looking to build AI chatbots and copilots for production use cases. So everything NVIDIA does is focused on open but commercial viable solutions that can be run in production and at scale. So of course it starts with our accelerated computing infrastructure. We have a number of different options. Consume it how you will, based on your use case, based on your preferred vendors and location. This runs literally anywhere, on-prem, in the cloud, in the data center. Then we have our NVIDIA AI Enterprise suite of software. This provides an enterprise-grade platform for you to build all of your projects on top of. So even if you're just in the POC phase, choosing NVIDIA AI Enterprise components is going to give you those stable branches. All the benefits of open source, you get that fast innovation, but you're ensured that these branches are optimized, they work together, they've been tested, they have stable APIs. NVIDIA AI Enterprise really provides that peace of mind when it comes to looking for something that you want to actually roll out in production. On top of this, of course, we have our various platforms for generative AI. Nemo is designed for language and helps you build those AI chatbots. We then have BioNemo for life sciences and drug discovery, and of course, Picasso for visual content. All of these together make up the NVIDIA generative AI platform. Now, of course, when it comes to building generative AI, we'd be nowhere without the AI foundation models that help us, get started quickly so that we don't have to go build from scratch. NVIDIA, we're committed to helping you fast track that development of your models by not only providing you with models that we've built and we've curated from our own data sources that are responsibly sourced, but also taking foundation models from the leading community providers and making sure that they're accelerated on our infrastructure. We know that this, all of these LLM tasks are highly compute intensive, so we want to make sure that they're optimized with our hardware and our software components so that they have the absolute best performance when they're running in your environment. This gives you higher throughput, of course, lower cost when it comes to the overall running of the systems, and it helps you, get those models out there quickly, whether it's from a, training at scale or running an inference. Now, don't take our word for it. We want to make it easy for you to experience all these models so that you can test which ones are best for your environment. On our NVIDIA NGC platform and our NGC catalog, you can actually go in and try the models through a GUI, or if you want to, you can access them through API endpoints and build them right into your systems directly from the NGC catalog. Now, I talked about the different platforms we have. You obviously have your models. You choose the model that makes most sense, and then you're going to want to either develop that model, continue to add your own data to it, or deploy it at scale. And that's where the NeMo platform comes in, because it gives you everything to do from training to customization to deployment at scales to obviously protecting that model with guardrails. NeMo is an end-to-end platform. So no matter where you're starting, whether it's at inference and with retrieval-augmented generation, which we just talked about, all the way back into customization, or if you choose to build a model from scratch, we have tools that are going to make this easy for you. They're all built together, they are designed to work together, and they're all part of our NVIDIA AI Enterprise platform so that you have the trust of our enterprise software to run in your environment. Now, we talked a lot about retrieval-augmented generation today. We recently announced our new NeMo Retriever solution that's going to make this even easier. So all the things that Jacob showed us and how you can build these solutions, we have a microservice under NVIDIA NeMo that is now early access. Let's take a look. So NeMo Retriever, this is a newly announced state-of-the-art, lowest latency service for retrieval that helps enterprises who are looking to build out retrieval-augmented generation solutions with an open and commercially viable solution that they can build on top of. So NeMo Retriever has a number of different pieces that are available under it. It starts with models, training, embedding, re-ranking models that can be trained and improved for their own accuracy. We then have embedding, retrieval, re-ranking, personalization, and evaluation microservices that help you as you're going through that process of POC into production. These models are commercially ready NVIDIA AI Foundation models that are built for state-of-the-art accuracy. This is important because, of course, you want the information that comes out of that vector database to be accurate with the prompt that the user puts in. They also have low latency and high throughput so that you get the best possible, fastest responses, but also are able to produce as much prompts through the system as possible so that it can produce tokens and you aren't spending additional cost. And then finally, as part of the NVIDIA Enterprise solution, it is, of course, production ready with enterprise support so that you can deploy with confidence. All right, so we've made it through the presentation. We've talked a lot about how to build these intelligent AI chatbots and copilots for your business. What are the next steps? Of course, the first thing is getting hands-on access to our retrieval-augmented generation workflow that it will enable you to quickly build out your own examples of these AI chatbots for your environment. This is available today open source through GitHub, so anyone can get access and get started really quickly. Now, if you don't have your own infrastructure or need a little bit more hand-holding as you're getting started, you can go to our generative AI chatbot workflow page and sign up to get access to our Launchpad lab that will be available shortly to help you get started with this environment.
Thank you for those insights. So I want to talk a little bit about what this means for you and how does it link to Microway. How do you take retrieval-augmented generation to the next level at your organization, and how can we help as a partner in that process? So when you think about a retrieval-augmented generation workflow, there's really two halves. There's the half on the left where you bring in your foundational model, you issue your prompts towards it and receive responses back. There's the half on the right where your enterprise data, is loaded, potentially pre-processed, and then brought into a vector database. The critical path is the interaction between these two paths. So you require a place in most instances to bring in that existing corporate data set and create those databases on. And that's exactly where Microway can be a partner who can assist in helping you deploy your workload. We can architect, build, and integrate the hardware deployment that you do this critical work on. There may be smaller models that you're trying to develop as you embark on that journey, or some ETL work that's required before you can even load data into the database. And potentially if you're going across your enterprise data and have a huge amount of work that needs to be done, you might be training fully custom models based upon your entire enterprise's data. In each and every scenario, Microway can be the partner that helps design and deploy the hardware that you're doing this critical work on. So why is Microway the right partner for your generative AI deployment? There's really 5 big reasons. First, we've had over 40 years of experience in designing and then helping you to deploy hardware and software for the AI and HPC space. Second, we customize the solution really for your particular workload, for your particular needs. We'll listen to how large your data set is, what kind of throughput you're looking for, what's the requirement from a time to train standpoint, and help tailor the solution to meet those particular needs. And that can also stretch between the compute and the data plane. Some customers have extremely large data sets, might need an incredibly large storage solution. Compute side might be particularly intense for other customers, and they might need to scale up much more than others. And also the fabric and networking in between. You need to ingest your data at a particular rate. If the pipe's not big enough or the latency is too high, then you won't be able to keep pace with the workload. And our experts in our solution architects and our technical sales teams can help you tailor the solution to those particular needs and ensure that you keep up with the demands of your particular workload. Third, we're an NVIDIA NPN Elite partner. We've been integrating NVIDIA DGX and HGX systems since their introductions, and we've been designing and architecting systems for NVIDIA data center GPUs since NVIDIA data center GPUs have existed. And that longevity and that partnership really helps us to execute for you. The fourth is our end-to-end support. We really help assist you from soup to nuts on your deployment. We'll begin with a design consultation, learn about your environment, learn about your data sets, and continue all the way through, yes, the procurement and the build, test, and integration process, but also post-deployment services, whether that's an on-site installation or something similar, and post-delivery services and support as well. And then fifth, we deliver ready-to-run systems. This means that we do the hard work of test and integration, test with stress tests that are known to cause faults in the fields that are based upon real workloads. We actually run real training jobs before our systems ever leave the factory, and integration. The integration from the NVIDIA DGX OS all the way up through NVIDIA AI Enterprise and NVIDIA Base Command Manager, potentially on your larger deployments as well. The AI software integration that's required for you to have a fully operating system that runs a real training job immediately after delivery. The delivery experience we have is for an end user to essentially receive the crate, open the crate, rack and plug in the system and be running a real training job on day one from those actions. So what kind of systems can we build for large language models, generative AI, and retrieval-augmented generation? We can build systems at all different kinds of scale. Kind of here on the left, if you're deploying retrieval-augmented generation, you're using a cloud foundational model, you just need to do a little bit of that, that corporate data integration. We can build you a workstation with NVIDIA RTX professional GPUs that allow you to inject retrieval-augmented generation into that overall prompt type workload. Yeah, as you scale up, right, you may have that first on-site deployment. You're doing that initial interaction with large language models, that initial work with generative AI. You're trying to also bring retrieval-augmented generation into the use case. You're taking RAG and then potentially retraining a little bit as well. That first on-site deployment, we can architect the right DGX H200 or B200 deployment for you. Install large language models at Microway straight from NVIDIA and GC. And then as you get to kind of the medium and the large scales, the medium scale NVIDIA DGX base pod, for example, where you're scaling up that AI application and you need the faster data integration that comes with integrating one or more DGXs, DGX H200 or DGX B200 with parallel storage and the networking pipe that's required to feed them. And then finally, at the very large scale, if you have an enterprise wide initiative here where you're trying to bring in all of the data across the enterprise, potentially train a new model based upon all of the data that you have spanning the enterprise, that's a DGX SuperPod scale of workload. And we can help you in the customization of the NVIDIA DGX SuperPods scalable units towards your particular needs and your particular site. So where are there notable microwave generative AI deployments? So we have generative AI deployments and customers across all kinds of different spaces, but a few notable ones here across in the defense and federal systems integrator space, which has built an AI center of excellence based upon NVIDIA DGX base pod scalable units for large federal systems integrator. They've been exceptionally happy with the deployment. We've built a teaching center for AI, or the hardware for teaching center for AI, and a hub for AI research for a large research university here in the United States, where they can teach AI to students across the campus, and also their researchers, their PIs can bring AI towards their existing simulation workloads and begin to scale up with a new method of computation. Also of note, we were actually the first partner to deliver an NVIDIA DGX A100 to a public sector customer at the launch of that platform. And we've designed, architected, and deployed large NVIDIA HGX platform and PCIe data center GPU deployments as well. These are across both AI and HPC. We have customers with thousands of total GPUs deployed and who are exceptionally happy with the quality of the hardware and software deployment that we've built for them. Microwave for now. Coming back to retrieval-augmented generation, when we have been starting to architect deployments for customers and to dive deeper into this workload, we kind of really amazing webcast about 12 RAG pain points and solutions for those pain points that we think is really relevant to all of those on this webcast. It's available on YouTube. We'll have a link for you at the end. There's actually an accompanying article from an expert who now is at NVIDIA, Miss Wenqi Glantz. She outlined 12 of the key RAG pain points, and then most importantly, started to propose some solutions for each of those pain points that can help you when you're trying to implement that first RAG workload. So to give you kind of a feel for what one of these workloads looks like, and you're probably already familiar, so we've done a little bit of scrubbing of this diagram, but here is kind of a process diagram of a retrieval augmented generation workload, and what's going on behind the scenes. And there's a lot of ways that one of these workloads can potentially encounter a hiccup. And those pain points you can really resolve with some of the solutions that are outlined here. And we'll dive a little deeper into this as well. A little more about that process diagram, right? Here's exactly what a retrieval augmented generation workloads diagram might look like from a compute standpoint and from what's just going order of operations wise, behind the scenes. And you can see that at various different steps in the workload, you might have a pain point or potentially a blocker to your rapid execution of the workload, or just simply a failure point, that's at any of these stages. And there are solutions to each of those potential failure points, that you can outline and begin to implement to have a smooth retrieval augmented generation workload. And here's 12 of them that, Wenqi Lance was able to outline in this amazing webcast that we really do recommend for everyone right here. I'm going to think about a few of these specifically. 3 different steps of workload, each that potentially have a challenge behind them, right? The first, if you have missing content, right, that's coming up, you're not finding results in retrieval augmented generation workload. Well, an easy solution for missing content can be both cleaning your data and also adding better prompting, right? Think about this as garbage in, garbage out, right? If you have a better database, a better knowledge base, you will get better results. And then also, if you prompt your knowledge base well, right, if you have clean prompts, better prompts, you're going to get better results. Next, if you have missing top ranked documents, right, you would think that, XYZ should be a result, but that's not the case. You want to try to deploy hyperparameter tuning and also some re-ranking. So tune your hyperparameters. That means potentially change your chunk or batch size, right? And also, have the ranking algorithm, utilize the top N or top K most probable tokens, right? Increase the most probable tokens that it delivers in the result. That way that you can have more relevant results appearing when you issue the prompt against the model. The third, having a challenge with data ingestion scalability. So you have so much data that it's taking far too much time to ingest it. The underlying algorithm might be running serially. Well, guess what? Parallelize your ingestion pipeline. This is exactly like an old HPC adage as well, right? If you parallelize the workload, you're going to have much faster time to solution. This goes for your data pipeline and your data ingestion pipeline as well. You can have outsized dividends to this because once you start to scale across massive parallelism, you'll have a much faster time to ingestion. If you're processing 100 million plus documents from your enterprise, that's going to be the time consuming part of the workload. And if you parallelize just that most time consuming part of the workload, you'll have outsized dividends. So these are just 3 important solutions, but we think they're the ones that solve kind of many of the most common or most frequent RAG pain points. There's 12 different solutions for 12 different potential problems that come in the workload. We really do recommend the webcast. We'll have links for you here at the end of our webcast. And a reminder, going back to what Amanda and Jacob really introduced earlier, if you're building that production AI chatbot, right, there's a very clear workflow path that you can implement that's based upon NVIDIA each step of the way, right? That will help you be successful in this space, and it starts with identifying that POC use case, because it helps you prove out the solution for every use case across the enterprise. Setting up that POC environment, we can help you design the hardware and software for that POC environment. Yes, going and building that retrieval-augmented generation workflow, that's the actual the meat of the work here. And the thing that's really special about this new approach towards computation, this new approach towards your enterprise data. You got to evaluate performance. Once you've built that workflow, does it perform up to your standards? Is it able to respond in an adequate amount of time? And then, okay, you've built the prototype. All right, you're doing really well with the introduction of this chatbot. All right, how do I scale up? How do I move the workload to a more production environment and let it loose with end users across your organization? So before we begin to wrap our webcast today, I want to play you just a short 90-second video about how Microway can be the partner for you.
So
in
Microway
NVIDIA
is an
deliveries.
HPC specialist,
And
AI
building
specialist.
hardware,
We provide
software, and solution
hardware
planning
and
for
software
your
integration
generative AI
for
needs.
lots of high-tech deployments in the AI and HPC space. We're an NVIDIA elite partner, and one of the products we provide is the NVIDIA DGX. The NVIDIA DGX H200 system features 8 NVIDIA GPUs and 2 Intel Xeon scalable processors that deliver unprecedented computational power and exceptional performance to tackle any AI workload.
It's a powerful future-proof solution for organizations looking to lead in AI.
Our DGX customers range from large enterprise users to AI startups to major universities. All of these customers are pushing the boundary of AI workloads, from generative AI to large language models to AI-assisted simulation.
We work with the customer to ensure that the PDU works for the DGX and for any electrical connections in the data center.
Not all technology vendors are equal. Not only are we making sure that the DGX is fully tested, but everything that connects to the DGX, those are all fully vetted and tested by Microway. And it's super exciting to be part of an ecosystem where customers are receiving these and then doing work that's never been done before. Choosing Microway means partnering with a company that values innovation, customization, quality, and customer satisfaction. Our expertise, advanced technology, and exceptional support make us the ideal choice for your AI and HPC needs. We're ready to transform your possibilities into reality.
So you're looking to take some next steps with retrieval-augmented generation. Well, here's 3 ways. On the left, there's a great Medium article that dives deep with the 12 RAG pain points and proposed solutions, with links to the associated research paper where you can find all the technical details. If you're more of a visual or an auditory learner, we encourage you to watch this outstanding webcast about the 12 RAG pain points and dive deep that way. The featured expert is Ms. Wenxi Glantz. She really has some amazing insights about solutions for 12 RAG pain points, and she's one of the primary authors of the Medium article and also the underlying research paper as well. And if you're willing to take that next step and want to discuss how to design a deployment for this kind of workload, well, our team really does speak AI and HPC throughout the organization. And it's really unique to find a partner who can engage with you on that depth, and our solution architects and technical sales team really can. If you want a quick version of these links, we encourage you to go to microway.com/RAG webcast links. That's microway.com/RAG webcast links. And you can find all these resources right here in this slide with straight through click-throughs that enable you to get to these resources quickly. We really encourage you to reach out to us. We answer the phone and email directly with the teams that I mentioned, and we can get you the architecting help that you need to be successful when it comes to addressing these workloads. So with that, our webcast is concluded. We're really grateful for your attendance, and we hope you've learned a bit more about retrieval-augmented generation and have some ideas flowing maybe about how you might implement it inside of your organization. Our team will respond to any questions and queries that were submitted via chat after the conclusion of this webcast one-to-one. We really thank you for your time today and hope this has been really valuable for you in your own work and your own explorations with retrieval-augmented generation. Thank you.